All right, continuing our discussion of hardware, let's talk about the brains of the computer or the CPU. The CPU is where all of this data is processed. So on the CPU, as pictured here, there's a bunch of transistors, and these transistors will change state, either on or off state, corresponding to the binary that's being fed into the CPU to process nearly all of the data that comes through the computer system. So the CPU is extremely important for performance of a computer. So when you go out and buy a computer, you should be concerned about your CPU performance depending on what you want to do. So how exactly do we measure CPUs? The first way that we measure CPUs is through clock speed. And our clock speed is just the pure raw speed that data goes through the CPU. So the way that a CPU operates is they operate in cycles per second, or hertz. And each second, the CPU is capable of processing X amount per second, and that's our clock speed. So for example, if we have an 800 megahertz processor, it can process stuff or data 800 million times per second. So a gigahertz is 1 billion times per second that clock is operating. And additionally, our CPU isn't just measured through our clock speed. That's one very important thing, but we also have a number of transistors inside of that processor. And those transistors, the more you have, the more data you can process every single tick of the clock. Additionally, we have cores, which are logical processing units inside of that CPU. So with a traditional CPU, you can only process one thing at a time. You add an additional core to it, you add something like a multiplier where you can process more than one thing at a time. So if you have two cores, theoretically, you could process two different things at the same time. If you have 4 cores, 4 things, 6 cores, 6 things, so on and so forth. We also have cache, or temporary storage space, on a CPU. And as a rule of thumb, the more amount of cache you have, the better performing your CPU will have. We also have hyperthreads, and your hyperthreads are the number of lines that you have into your CPU, and these can act a lot like the cores because you have X amount of transistors that you have available in your CPU. But not every single task is going to require the use of all those transistors. So adding additional threads into the CPU allows you to move more than one piece of data through that CPU at a time, so it can ultimately speed up the processing of your CPU. So this is why when you see modern CPUs, for example, you have your Intel i3 that might be 1.7 gigahertz, and 15 years ago we had a 4 gigahertz Pentium processor. Why that 1.3 i3 is faster is because it takes other technologies into account, such as transistor count, number of cores, number of cache, and hyperthreads on the processor, which the Pentium 4 just didn't have. So when you're buying a CPU, well, how do you make sense of this all? If a 4 gigahertz processor isn't necessarily better than a 2 gigahertz processor, then how do we know which is the best processor to buy? What you want to do is you want to look at the benchmarks of that CPU. And just to complicate matters further is because the computer system works as a whole. So we have all the software and all the hardware working as a system. So your CPU isn't even the only factor. The CPU also has to play friendly with the rest of the hardware and software. And the better it plays with that hardware and software, well, the faster that computer can go. So what you want to do is you want to look at benchmarks specific to the tasks that you're doing. So if you're really into gaming, you want to see which CPU is best for gaming. If you're really into video editing, you want to find out which CPU is best for video editing. If you really want a long battery life so you can perform office tasks and watch YouTube videos, well, then you're going to look for a processor that's suited for that. And they have processors that are suited for all of those tasks. So you want to go out, you want to look at the benchmarks, go to Google, find out what the best processor for your purpose is. So the last thing that you need to do for this unit is I want you to go ahead and work on this activity. Given this is an online class, you will not be working in groups. And what you'll do instead is you're going to look up each of these processors on Google or Yahoo or whatever search engine you want to use, and you're going to find out the purpose of that processor. So what's an i3 good for? You've seen i3. What's it good for? About how much does an i3 cost just for the CPU? And then find out the wattage of that. And why you're going to find out the wattage is you're going to see that the lower the wattage of the CPU, usually the less power it has, but the greater the battery life you have for your computer. Same thing with an i5. Find out what the purpose of that is, the cost and the wattage. i7, purpose, cost, and wattage. Core M, then Xeon, AMD A6, and AMD A8. So go ahead, fill out that chart, and you will submit that chart to the appropriate area on Moodle so that you can demonstrate to me that you've been able to look up, research the various computer components so you're more informed the next time you're going shopping for a PC.